Hey class, in this video I will be going over a bit of an intro to our 3D design unit. This is the last unit we'll be covering this semester, and it's a little bit shorter because we only have a couple weeks before exam week. Um, so it won't involve as much, but we will still cover some things and have a fun project to end the semester with. In this video, I'm just going to be kind of talking about some of the basics of 3D design. So you can see I'll be talking a little bit about how 3D design works and some industries that we use it in, and then going over some of the basic terminology of 3D modeling. Um, uh, in, in this unit, we're going to be doing something a little bit different. I'm not going to have a video tutorial for this week. Instead, there's an interactive tutorial that you can go through on the website for the software that we'll be using. It's actually not the software you see here. This is Blender. This is a little bit more of an advanced 3D program that I use for my work, but it's going to be better for me to kind of show some of the basics in this video. But this isn't the software we'll be using in class. Instead, we'll be using a program called Tinkercad, which is just in the browser. So it's really easy to use on any platform, and it's pretty straightforward. So for this week, instead of following a video lesson, I think it would be cool to go through their their tutorials to onboard you to the program. It's interactive, so when you start the tutorial, it kind of gives you instructions and you kind of follow them, and it's really fun actually. So I thought that would be good for this week. Next week, I'll do more of a demo and demonstrate creating like a project from scratch as sort of a creative project that matches the assignment we'll be doing with this project. So for this week, we'll just kind of learn some of the basics, get used to using Tinkercad software, and then next week we'll do a pretty short sort of creative exercise. So before we get into it, I'm going to show this little clip from The Simpsons. I think this does a pretty good job of capturing the difference between 2D animation and 3D animation. I have this muted, so hopefully I won't get a YouTube copyright strike. But in the beginning of this clip, we're going to see 2D animation, and you won't be able to hear it. So, I'll have to explain the plot a little bit. Or actually, the plot doesn't really matter. We'll just watch the clip. But we'll look at some 2D animation, and then it transforms into 3D animation. So I think this is a good way to see that transition. As we're watching this, one of the things you'll notice is that our characters are always kind of like facing at very specific angles because they're all 2D drawings, and there's a lot of drawings that you have to make to kind of animate things, especially on a big production like this with lots of scenes and lots of cuts. They really need to do things very efficiently. Now, Homer escapes into the closet and then suddenly is in this 3D world. And look at how much smoother these transitions are when you're using 3D graphics. You don't have to draw every frame. You make a model and then use a camera to zoom around in the scene. And so you have a lot more angles that you can view it from and a lot more data that you can work with. So then we go back to the 2D scene, and let's skip ahead. And here we see Homer in the 3D scene. And so we've looked at 2D animation. We've been working mostly in 2D in both our animation and our Photoshop project. And even our web project is 2D, although we're not using graphics software for that. But now we're going to take a quick look at 3D design and 3D software and 3D modeling and kind of talk about the differences. All right, so that's our little intro. The basic difference, the main difference between 3D design and 2D design is obviously we add a third dimension, but that adds a lot more complexity in a couple ways. One is that now we have to think about the perspective of the viewer. And so that adds a lot of complexity on its own. Instead of having an implied perspective of the 2D plane, we now have we have to define the perspective of the viewer or the camera. And then we have to do a bunch of fancy math, which obviously we don't have to do. The software is going to do it for us. But we have to do a bunch of math to determine how to draw an object on a 2D plane using 3D representations. before we get into actually drawing this out and explaining this, let's talk a little bit about where we use 3D design, and then we'll probably go over into Blender and stay there for a bit. So there's a lot of industries. It's probably pretty obvious. Like I'm sure you guys have seen a lot of 3D graphics in movies, so entertainment and media. But there's obviously also a lot of 3D design in architecture and product design and manufacturing. All of these are industries that will start with 3D models and sketching and building out designs in 3D. In industries that use a lot of manufacturing and hardware, things like the auto and aero industry, medical industry, healthcare industry, any educational or training, 3D printing, all these things are going to use 3D software. And so you can probably imagine a lot of those things. Being able to use 3D software is a great skill to have, and it's something we're just going to touch on. It's something obviously you could explore more if you take some of the 3D animation classes or other classes at BMCC. All right, so let's jump over into Blender, and it'll give me a chance to kind of talk about some of the basics of how 3D design works and show some examples. So this is Blender. This is a free and open source 3D modeling and animation program. I use it in a lot of my work. There's lots of different 3D animation programs. If you're an animation major, you'll probably use Cinema 4D, which is another big one that's kind of an industry standard. I tend to prefer Blender just because it's open source, so you can program it and do other things with it, and there's a great community and stuff. Anyway, they all kind of basically work the same, so I'll just kind of jump in and kind of explain a few things. So when we first open Blender, we're going to see a little scene like this, and this tells us a little bit about what we're going to get into. So we have a cube, which is our first little bit of geometry. And you can see when I'm using Blender, a lot of what I'm doing is just manipulating this view on the cube because, as I mentioned, there's no longer an implied 2D perspective. There is a explicit 3D perspective. So, of course, our computer screen is still 2D, so we're rendering graphics in 2D, but the space that we're sort of representing is a 3D space. And so we have to move around that space and change our perspective on that space. There's also a light, which we'll talk about in a moment, and then there's a camera over here. I'm going to get rid of all this stuff, so I'm just going to select this stuff and just delete it, and we'll start from scratch. And I just want to kind of talk about, again, how we work in 3D. So let me go into just a second. All right, sorry, I had to change a setting. Okay, so usually when we're doing 2D graphics, if we're doing animation or Photoshop or something like that, we have this 2D plane. And when we say 2D, what we mean is there are two dimensions. There's the X dimension, which is horizontal. So all the pixels going from the left to the right side of the screen. And then we have the Y dimension, which is vertical. And that shows us all the pixels going from the top to the bottom of the screen. And so, when we design something in Photoshop, there's a square, and the square has some properties like how wide it is and how tall it is, but there's no depth. We can change the size of the square, we can move it around, but we can only see it from this one perspective. So the perspective of the viewer, let's draw our little viewer down here, although he looks like he's facing away, but that's okay. This perspective of the viewer is always kind of implied. So we don't have to worry about if people are looking directly at the screen because, if they're looking at it, they're looking at it. In the case of 3D, when we imagine a 3D object like that cube that we just saw, we will see the object differently based on how we're looking at it. So if we're looking directly at the cube, we'll just see a square. If we rotate the cube down a little bit, we might see something like this, like a little edge right here. We might see a little bit of the front of the cube and a little bit of the top of the cube. If we then rotate around here, we might see something more like that. We might see the top of the cube up here and the side of the cube here and the front of the cube here. So there's this implied perspective where we're looking from. But the screen obviously never changes, so what we have to do is move what we call a camera. And so the camera sort of sets the perspective, and then we calculate what the shape should look like using, some fairly complicated math that we're not going to get into. But we calculate what the shape should look like, where the edges should be, where the faces should be, where each point should be. We do some calculations to determine what that will look like as we move our camera in space, and that's what we draw on the screen. So when we're designing in 3D, we have to kind of move around the space to see how things look. And so there's a few different things that 3D software usually let us do that may be a little unusual. So I'm going to add this box back in. I'm going to bring in our cube. And so there's our little cube. And so a cube and any 3D object is what's called a mesh. And so a mesh is a combination of two things. One is the geometry of the object. Geometry is just like the points in space and how they connect together. And then the other is the material, or this is also called the surface. So the geometry is the points in space and the edges and the overall shape. And then this material or the surface is the sort of like skin that we wrap around the geometry to visualize that geometry. And that contains things like the color, the texture, the lighting. All of those things are reflected in the material. So every object that we add into our scene is called a mesh. And the mesh is a combo of the geometry and the material. All right, so let's take a look at this a little bit closer. So one of the things I can do is go into wireframe mode, and that'll show me just the geometry without the surface. You can see then I have this surface mode, I have the material mode, which we don't have a material, so we don't see anything there. And then we have the rendered mode, which is when we put everything together at the end. I'm going to go back into the object mode for a second. I can also make it sort of see-through, so I can see through to the other side of the geometry with this button. And then if I go into edit mode, you can see and change the actual geometry. We're not going to be able to do this in Tinkercad, so don't worry about this. I'm just showing you guys this as an example. So with our box, there's a few things that make up our geometry. One is these points in space. These are called vertices. And we can move these around, and when we do, it changes the way that the box looks. And we can scale these up, we can rotate them around, we can do all these different transformations to this box, just like we could rotate and scale and do things in Photoshop, but now we're doing it in 3 dimensions. Besides the vertices, we have what's called edges, and these are the sort of combinations, the lines that connect the vertices. So if 2 vertices should connect, we draw a little edge. And you can actually get rid of one of those. Let's do that. And now we have a slightly different shape because we lost some of the data. I'm going to undo that real quick. And then finally we have faces. So the faces are drawn in between the edges. And it goes even deeper than this. There's a lot. 3D design really gets quite complicated. Like we could look at, if we go into the vertex, we could even look at the normals. So we could look at the face normals, and these are little lines that kind of show us which direction the faces are going in. So these are kind of facing outwards. There's a whole lot of stuff that we can kind of get into, but we just want to kind of talk about the basics. So I'm gonna go ahead and turn that off. So that's our basic geometry that kind of makes our mesh, and we have lots of different types of geometry. So I'm going to delete this, and let's look at what else we have. We have a icosphere. This is another type of geometry that combines a bunch of triangles to make a little sphere. And let's see what else we have. We can make a cylinder. This is what it sounds like. It's 2 circles with a tube in the middle. We can make a cone. That looks like a cone. We can make a torus, which is like a donut. And all these things have properties. I can kind of change how many segments there are in the torus, and how many rings there are, and how big it is, and how big the inside is. So we have lots of control over all of the geometry when we're making a 3D model. So now we have this little donut that looks pretty cool. Another thing that we can do is add to the resolution. So you can see all the points here, and so we can see these kind of flat surfaces. But if I hide myself for a moment, if I go into the modifier and I just add a little modifier here, I can add more data. And as I add more points, notice that this donut gets more and more smooth. And so let's do one more. We'll make this really exaggerated, and then I'm going to apply this. And now you can see there's lots and lots of points, and they're all connected by edges, and they're all connected by faces. And so as we add more data, we get more resolution, we get kind of a smoother model. That, of course, adds more data to the computer, so it makes the file size larger. And 3D files tend to get pretty large pretty quickly, depending on kind of what you're making. But that's a basic relationship between geometry and our mesh. Okay, so we've looked a little bit at the geometry. Let's talk a little bit about the perspective. So when we're editing, we usually have different views. So I can kind of like rotate around and look at different views, and you can see this little axis up here. So you can see that this point's y is left and right, z is up and down, and x is or actually y is kind of like forward and back, x is left and right. This is actually flipped from what most 3D design programs use, where z is facing towards us. Blender, for whatever reason, they have y kind of facing towards us. So if I go into front view, you can see y is pointing at us if we look at this here. If I go into right view, you can see x is pointing at us. And if I go into top view, you can see that z is pointing at us. And if we transform our mesh in different ways, it'll change the way we see it from all these different perspectives. Another aspect of how we see it is the perspective versus orthographic. So if I take this donut and I switch to orthographic, we just see kind of like a flat donut. Versus perspective, the front of the donut looks like it's closer to us. And let's make a copy of this donut actually, and I'm gonna just move it way back here. And we'll see again, when we're looking at this in perspective view, we can see one donut that's closer to us, I'm gonna move this down a little bit, looks really big. And this donut that's really far away looks small. That's basically how perspective works. Things that are smaller away look smaller, and they kind of move towards a point on the horizon. If I switch this to orthographic, suddenly these guys are the same size. This just shows me the 3D geometry without any relationship to this vanishing point or this perspective. So orthographic is good if I'm like designing a building and I want to see it, from the top view, and I want to see how far things are going to be apart and exactly, what they should look like. That's good for architecture, for 3D modeling, for making designs for products and things like that. For art, we tend to look at things from perspective, because eventually we're going to render this into an animation. And if we're telling a story about these two donuts and one donut is going to run up to the other donut, we want to see that as though it's in real life. So our camera view is really important. And when we animate, we typically have a camera in the scene. So I can add a camera here, and I'm just gonna move the camera. Oh, I put it over by that donut. Let's just reset it. And I'm gonna reset the rotation. Okay, and so I'm gonna flip the camera up. Actually, let's just rotate it on X and go like that. And then I'm gonna move it back on Y. And so now we can actually look through the camera view. And normally what I actually do is I set this all the way. So now if I look through the camera, I just see our donut. So now a lot of time when we're designing in 3D, we'll actually have a bunch of windows open. So Blender makes this really easy. I can drag as many windows open as I want. So let's drag some windows open, and let's get rid of some stuff. Again, Tinkercad is a lot more simple than this, but I'm just giving you guys a little taste of what this looks like. Okay, so I'm gonna use front view here. I'm gonna use right view here. I'm gonna use top view and then camera view. So notice down here, if I take this camera and I move it up, notice that the camera view changes. Everything else stays the same, but the camera view changes. And then if I take this donut's over here, but let's move it back here. Now I've got this donut over here. And so I can look in the top view and I can kind of move it around back and forth and we can see the result in the camera. Or if I need to go up and down, maybe I'll go over here to the front view and I'll bounce it up and down like that. And then somehow this guy got out of side view. Let's go back here. So we have these three different views or three different angles on which we can view our animation as we're designing it, but ultimately we're going to have this camera, and the camera is the single view that we're going to render out as an image or a video or an animation file when we're finished with our 3D model or our 3D animation. All right, so I've already talked about a lot, but there's a couple more things I want to just go over real quick. So one thing is that in 3D design, another thing besides the mesh and geometry in the camera that's really important is the lighting and the surfaces and materials. So when we're designing in 3D, we're often not just working with like colors the way we do in Photoshop. We're usually working with lights and a scene and how lights and materials interact with each other. So I can add lights. Let's just add a quick light. So I'll add a spotlight. This is a little bit specific, but we can just drag the spotlight up and I'll move it up, or I gotta move it over here. And we'll put a little spotlight on this donut. And right now we don't see the effects of the spotlight because we're not in the material view. But actually, I'm just gonna make this the full view here just so you get a better look at it. And I'm going to turn off some of this stuff. And so if I go into material view, now we see a little bit of the effects of the lighting. Or if I go into rendered view, or actually I don't have that set up. So let's just go in material view. Okay, so if I take my light and I change the color, it's going to influence the color of the texture. Actually, let's go into render view and I'm just going to turn this up. There we go. Okay, so notice how the light kind of falls off across the donut. Because light, doesn't apply evenly to an entire surface. It applies relative to where it hits the surface. So if I move this light over here and then I kind of angle it this way and then maybe move it like that, see we get less light. So we have a lot of dynamics that we can add by using light and using materials. I'm going to choose a slightly more neutral color for my light, and then we're going to add a material. So I'm just going to add like a warm yellow for that light, maybe a little less bright like that, maybe a little orangey. Okay. So the other thing that we have is materials, and we haven't added a material yet, but if I click on my model, I need to make sure to click on the model, and I go down to this materials panel, and I'm going to create a new material. Now we'll see the result is a combination of the material and the light. So the material, again, is the kind of the surface of the model. So our mesh is our geometry plus our material. So we can change the basic color. So if I want like a red donut or a blue donut or a pink donut, you can change that color. You can add more colors, but that gets a little more complicated. But then we can set things like how metallic it is, like is it very shiny? We can have a very shiny donut. How rough it is. If it's if it's less rough, it'll appear kind of more shiny, more sort of metal or like a plastic. If it's more rough, it'll kind of spread the light around a little bit. So we can kind of play with those values. And then we can also draw textures. So textures are like images that wrap around the material. So if I go over to the texture paint area, this is like a whole new area, but let's take a look at it for a second. So we can add a little texture in here. Again, we're not doing this in class, so don't worry if this seems very confusing. But we can take a texture and then we can kind of draw around on the model. I made it a little too big of a brush. So I can draw over here, or I can draw directly onto the model over here. And so we can kind of design something cool. And this is actually just a 2D image. Like this is an image that you could make in Photoshop and then throw onto your donut. So that looks pretty nice. Maybe I want to fill with a different color so it's a little more dynamic. So I'll just fill like that. Okay, so that looks pretty cool. And I keep saving, I don't need to save this. So let's go back, and there's our resulting donut image, and maybe I don't want it to be quite as rough. And there we go. So we have all those things kind of combined together to make this image. But ultimately, at the end of the day, with our 3D model, we're still rendering on a 2D plane. And so when we finish with all our animation, our modeling, we're going to export either an image or a video. So we'll go over to our rendering tab. We'll go to, render an image, and it'll combine everything down together, and it'll create this image, and you can save that image. If I go to image, save as, I'll just save it. Let's save it to the downloads because I usually don't have anything in there. Click save as, and let's go to my downloads folder. And there we go. There's my donut image. And that's a regular image. That's a PNG. I can post that on the class blog or do different things with it. Sometimes you can also export a 3D model as a file to use in a video game or another animation. So that's another way that sometimes you'll export the data of a file. But typically, if you're designing an image or an animation, you're going to be exporting an image file or a video file, just like we've done in some of our previous units. All right, so I think that's everything that I wanted to cover for our little intro. So hopefully that gives you a little bit of an understanding of how 3D modeling and 3D design works. As I said, we're going to be working in a different software, which is Tinkercad. There's going to be a link to this on Brightspace. So this has all the same features, but it's a little bit simplified to make it easier to get started. So there's a bunch of little tutorials that you can go through to learn how to create and manipulate and add objects and change colors and stuff like that. I think this will be pretty fun and shouldn't take too long. And then next week, we'll go over actually creating a project with this. So you want to get started, you can look at the project requirements on the class page. We're going to be working on recreating a sculptural artwork. So you have different options for that, or you can, come up with your own concept. And that's what we will be doing for next week and basically for our last project for the semester. All right, I will see you guys in the next video.